Do you ever have low energy levels? Perhaps have pale skin, feel short of breath, irritable, or even have mouth sores? Well, these are some symptoms of folate deficiency. In today's episode, I continue our Vitamin Miniseries and discuss the importance of this vitamin for mental health, nervous system health, cancer risk, dementia, and heart disease. However, for this vitamin, more may not be better. Keep listening on for more details, only here on the People Scientist Podcast. You are listening to the People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back to the People Scientist Podcast for episode 47, where every week I arm us with some scientific evidence so we can all lead the healthy lives that we want to live. On today's episode, we are continuing our Vitamin Mini-series and jumping to the vitamin folate or folic acid. This is another of the B vitamins that has a very important role in our overall health. This vitamin is a bit different in regard to its function and the role it plays in our health and risk for disease. So I hope you enjoy it. And as we always do, let's start off with some core takeaways. Folate is an important B vitamin that plays an essential role in the ability for our cells to divide and grow. So if we have a folate deficiency, we may first notice deficiency symptoms in the parts of our body where we have rapid cell turnover, such as in our stomach, intestines, tongue, and blood cells. Because folate is so important for cell growth and division, it is essential for pregnant women and their ability to produce a baby. As a result, unfortunately, low folate intake may interfere with the ability to produce a baby and could cause neural tube defects, such as spina bifida. Because of this, many countries instituted mandatory folic acid supplementation in bread flour to enhance the folic acid intake throughout the country. This has led to dramatically less birth defects. However, in contrast to other vitamins I've spoken about, where more of the vitamin beyond the recommendation may be needed to reduce the risk of chronic disease, here I think folate is different. The reason being is I spoke of how folate is important for cell growth and cell division, and this is beneficial for us, except for in the scenario of cancer. Folate is required by cancer cells to grow and divide. This is evidenced by the fact that cancer chemotherapy treatments are made to specifically block the effects of folate in order to prevent cell division and growth of the cancer cells. So folate may be a vitamin where we do not want to exceed the recommended amount. However, we definitely need folate to be healthy, so we need to make sure we get within the recommended level. And in today's episode, I will give you all the details on how to do just that. Now, let's get into those details. The history of how folate was discovered I find quite interesting. All the previous vitamins were discovered by men in the early 1900s, but folate was discovered by a female scientist named Lucy Wills in 1931. The history of how Dr. Lucy Wills discovered folate is documented nicely by Hofbrand in the British Journal of Hematology in 2001. Dr. Wills is quite impressive considering her attending university in the early 1900s when it was not as well accepted for women to be scientists. She studied botany and geology in her first degrees, and then attended medical school, so she became a physician. Now, similar to why the other vitamins were discovered, Folate was also discovered because a disease was inflicting populations of individuals, and in their quest to cure the disease, the vitamin was discovered. In Bombay in the 1930s, there was a very high prevalence of women suffering from a condition called macrocytic anemia, meaning larger than normal red blood cells. Now remember how I said folate plays an important role in cell division and growth? So cells that turn over more frequently in our body are the first to get impacted with a folate deficiency. Well, red blood cells turn over, meaning fresh cells are generated approximately every 4 months. But in situations such as in athletes and especially pregnant women, red blood cells are generated at a much faster rate. So as a result, if there is a folate deficiency, red blood cells may become compromised. What happens is the red blood cells may become larger than normal. Why this happens is because the cell will keep growing without the ability to divide into a new cell. The reason being is folate is essential for this division step. If folate is not there, the cell becomes large without dividing. So essentially macrocytic anemia. And these large red blood cells do not optimally function. So without optimally functioning red blood cells, many effects can occur on our health. The primary job of red blood cells is to carry oxygen to tissues and to carry away carbon dioxide. So if someone is deficient in folate, it may lead to low energy levels, feeling short of breath, feeling irritable, having pale skin. It can result in delayed growth in children, tongue and mouth sores, upset stomach, and diarrhea. Now, the cells in our tongue and intestines turn over very rapidly, so they are the first to get impacted as well, hence the symptoms of tongue and mouth sores and an upset stomach and diarrhea. So Dr. Wills noted that this condition of macrocytic anemia was highly prevalent in Bombay and even more prevalent in pregnant women. So Dr. Wills traveled to Bombay to study the women afflicted with this disease. She noted that the women who were afflicted with this condition tended to live in poorer conditions with a diet deficient in protein, fruits, and vegetables. So this led her to study the effects of diet and nutrition on this condition. She tried to replicate this disease in rats in order to find a way to cure it. She was able to induce macrocytic anemia in the rats with a similar type of diet that the women were eating. This was a key finding, which essentially illustrated that diet or nutrition was a likely cause to this disease. She then was able to reverse the anemia by feeding the rats yeast. Now, yeast is a natural source of many B vitamins and is actually the reason for the discovery of many of the B vitamins. Many people today will actually add nutritional yeast to their foods as a source of B vitamins. Now, nutritional yeast specifically is deactivated, meaning that the yeast is not alive and will not grow. And this is important because we don't want yeast growth in our body. So if you are going to add yeast to your diet, make sure it's inactivated or deactivated, and nutritional yeast is an example of this. So Dr. Wills essentially did that. She decided to offer a yeast extract to the women in Bombay living with this condition, and it indeed did reverse their symptoms and the condition of macrocytic anemia. Now, because of her work, we now know the function of folate, deficiency symptoms, and how to cure a folate deficiency. However, unfortunately, anemia in general is still an issue today. In 2010, global anemia prevalence was almost 33%. Can you believe that? That's more than 2.2 billion people were affected with anemia. The diagnosis of anemia can be determined from a blood test. Specifically, if you see mean corpuscular volume or MCV on your blood test, this is an indication of your red blood cell size and if macrocytic anemia is present. Megaloblastic anemia is caused by a deficiency or an impairment for the use of vitamin B12 or folate. Now, vitamin B12 deficiency is common to occur with folate deficiency, and sometimes it can be difficult to distinguish which deficiency someone may have, as their clinical features are actually quite similar in that they can both result in anemia. What we do know is that vitamin B12 deficiency takes much longer to develop versus folate, as there is approximately 5 to 10 milligrams of folate stored in the body, and this becomes rapidly depleted during normal cell division. Whereas vitamin B12 deficiency takes longer and perhaps even years to develop. So if someone is having an inadequate diet, their deficiency in folate can occur rather quickly. Now, folate has been studied in the context of many clinical situations. I would say the most studied is in the context of neural tube defects. Now, neural tube defects are birth defects in the brain and spinal cord. They develop within the first month of being conceived. The most common neural tube defects are spina bifida and anencephaly. Many clinical trials have shown the capability of folic acid supplementation to completely eradicate neural tube defect occurrence, such as in 1991 by the British Medical Research Council and again in 1992 in the New England Journal of Medicine. Unfortunately, neural tube defects can occur within the first month of pregnancy before a woman may even know she is pregnant. So many national organizations recommend that women of childbearing age who are sexually active should take a supplement of folic acid daily to prevent any neural tube defects. However, many countries observe that despite this recommendation, only 15 to 40% of women, depending on their age and ethnicity, were taking a supplement. So many countries decided to institute mandatory fortification of bread flour with folic acid in order to increase intake in the food supply and to reduce neural tube defects. Currently, 84 countries in the world have mandatory fortification of a staple cereal grain such as bread flour. Countries that have this mandatory fortification include, for example, Canada, the United States, many countries of South and Central America and Africa, and Australia. Europe and Asia largely have not implemented mandatory fortification. If you want to know if your particular country has mandatory fortification, I will include the link of the fortification initiative in the description box to this episode. But a lot of the times you can look at your nutrition label, and for example, here in North America, we will see fortified flour as an ingredient for a lot of products. Now, in today's age where we are more knowledgeable about folate intake, the question is who may be at a higher risk for deficiency, and are they going to know it? So what are the symptoms? Well, individuals that tend to have a higher risk of folate deficiency include those living with substance abuse, alcohol use disorder, individuals living with depression, individuals with uncontrolled malabsorption conditions such as Crohn's disease, women that are pregnant or breastfeeding, and those that have exfoliative dermatitis, which is a skin condition in which there needs to be a rapid turnover of their skin cells. Now, why these individuals may be at a higher risk of folate deficiency, I think for the most part makes sense and is logical. For example, we know that individuals with alcohol use disorder, they tend to have many deficiencies, which is related to both poor nutritional intake as well as an increased use of vitamins in their body. However, the connection with folate to depression is not readily apparent. So how is there a connection here? Well, Morris in 2003 in the journal Psychotherapy and Psychosomatics identified how individuals living with depression had lower folate levels in their blood versus individuals that have never been diagnosed with depression. And this finding has been replicated a few times. Bottiglieri in the journal Neurology, Neurosurgery, and Psychiatry in the year 2000 reported how low folate levels in the blood may be related to a reduced ability for us to make important neurotransmitters in our brain, such as serotonin, dopamine, and norepinephrine. And the ability to metabolize these important molecules may also be compromised. This could be a potential reason why low folate intake is associated with a higher risk of depression. Now, considering that folate is also important for energy levels and is related to feelings of irritability, which is a symptom of folate deficiency, it is evident that folate may be necessary for mental health and wellness. Now, I think it would be really interesting if they could take a group of individuals with folate deficiency and to run some functional MRI and PET scans on their brain to see the dopamine receptor binding capacity and signaling in their brain to see if there is a direct connection between the folate deficiency and the functioning of the brain. But to my knowledge, this has yet to be conducted. Now, folate has also been looked at in the context of Alzheimer's disease. Chen in 2016 in the journal Mediators of Inflammation recruited 121 patients newly diagnosed with Alzheimer's. Half of the patients received a placebo and half received 1,250 micrograms a day of folic acid, and they took these for 6 months. After 6 months, those receiving the folic acid supplements had a very slight improvement by 1% in their mental health and memory scores, whereas those in the placebo group dropped by 5%. Now, the data is not very convincing in Alzheimer's, there's only a couple of clinical trials, but perhaps there could be something here linking this important vitamin with mental health and cognition. Folate has also been studied extensively in the context of heart disease, as folate is very important in regulating the levels of the amino acid homocysteine in our body. Blom in 2011 in the Journal of Inheritable Metabolic Disease nicely reviews this topic. Now, a deficiency in folate can lead to a buildup of this amino acid homocysteine, and many scientists, including McCulley as early as 1969, reported that homocysteine can have a negative impact on the health of our blood vessels. Uland in 2000 in the American Journal of Clinical Nutrition even reported that mild elevations in homocysteine in the blood is associated with a higher risk of vascular disease. Now, vascular disease can include heart disease, cerebrovascular disease, which can lead to a stroke, and peripheral artery disease. However, in folate or folic acid supplementation clinical trials, the results are mixed as to whether or not this vitamin can prevent the risk for a stroke or heart attack. So even though there is a mechanistic connection of folic acid keeping homocysteine levels down, unfortunately, supplementation trials are not always clear as to whether or not this can be beneficial. Okay, now we are going to talk about the relationship between folate and cancer. And this is where the data is conflicting as well. Kamen in 1997 in Seminars in Oncology described how folate is necessary for our cells to divide and grow. And because of folate's role in cells multiplying and growing, blocking folate through medications have been very effective in the treatment of cancer. The most common chemotherapy agent, methotrexate, blocks folic acid functioning or folate functioning in the body. So this begs the question, can we take in too much folate? If we take in a lot of folate, does it increase our risk of cancer because of its role in cell division and growth? So here's the thing. We need folate in our diet to prevent cancer. As many scientists, including Choi in the Journal of Nutrition in the year 2000, reported how low intake of folate may predispose us to abnormalities in our DNA, such as being less able to repair our DNA. Now, reduced DNA repair means more mutations in our DNA, proteins, and cells, which can set us at an increased risk of cancer. Specifically, low folate intake is associated with a higher risk of colorectal cancer. So the important role of folate in our health, homeostasis, and ability to reduce cancer risk, I think, is apparent and well accepted. But again, it begs the question of what about too much folate? Now, extra folate is certainly required in women trying to become pregnant, who are currently pregnant, breastfeeding, and in some chronic diseases such as uncontrolled Crohn's and alcohol use disorder. However, otherwise, extra folic acid may not be necessary, as some clinical trials show. Overall, when I look at all the observational studies and meta-analyses, it appears that folic acid supplementation, so on top of what we're already getting from our diet, seems to have no effect on the risk for different types of cancers. Now, the supplementation amount ranged from 500 micrograms to 5,000 micrograms a day and taken on average for 2 to 7 years. But some studies have shown that high folic acid intake from supplements may increase precancerous colon cell growth, or it can be associated with a higher skin cancer risk. For example, Cole in 2007 in the journal JAMA recruited over 1,000 participants who recently had colorectal adenomas, which is a benign tumor of the colon or rectum. The scientists had half the participants take 1,000 micrograms of folic acid a day, and the other half of the participants took a placebo for more than 5 years. And they followed them and did colonoscopies to measure the lesions or adenomas or tumors in their colon throughout that period of time. The scientists found that the folic acid group had a 67% higher chance of developing an advanced lesion versus the placebo group. More specifically, 11.6% of the patients in the folic acid group had a new advanced lesion versus 6.9% in the placebo group. So, can high folic acid intake increase the risk of cancer? I think this is still a debated question. I would say it is possible, but more evidence would suggest no, that it doesn't, versus yes. But the data, again, is conflicting. So if you want a simple answer, I would say to stay below the tolerable upper intake limit for folate and folic acid, which is 1,000 micrograms a day. So in this scenario, more may not be better, especially if you are taking a multivitamin supplement. Take a look at your typical diet and add up how much folate you are consuming throughout the day to see exactly how much you are getting from your supplement and your foods. The reason why I say this is because Moodridge in the British Journal of Nutrition in 2016 reported that in Canada, those who took a multivitamin supplement may be at a higher risk of taking in too much folate. 18% of supplement users were taking in over the tolerable upper intake limit of folate, which again is set at 1,000 micrograms per day. This limit was set in order to prevent folate from masking vitamin B12 deficiency, which can commonly occur, and this could lead to severe neuropathy and nervous system damage if folate is masking this B12 deficiency. Now, some scientists and practitioners argue that this upper intake limit of 1,000 micrograms a day is set too low, and that we need to investigate the safety of higher doses, but this has yet to occur. Folate is also a little bit different in regard to having a tolerable upper intake level, as some of the other vitamins don't have that maximum set limit because the body is able to remove the excess of the vitamin quite rapidly via the urine and the kidneys. However, folic acid in supplemental form is a little bit different, as some studies back in the 1990s showed that taking in supplemental folic acid at even 200 micrograms a day, which is on the lower end, can actually result in having unmetabolized folic acid circulating around in the blood. So folic acid may not be removed, or the excess may not be removed as easily as some of the other vitamins, hence concern of that there is a possibility that we potentially could take in too much. Hence, that is the reason why a tolerable upper intake level of folic acid has been set, and why it hasn't been set for others. So now that we know folate is important for a lot of aspects of our health, and we know that there's a certain limit we should not exceed, let's talk about supplements, food sources, and the amount of folate in certain foods. Now, the recommended intake is set at 400 micrograms a day for adult men and women. For pregnant women, it is recommended to take 600 micrograms, and for breastfeeding women, 500 micrograms a day. Now, it is here that I need to make a distinction between folate and folic acid. Folate is the natural form of this vitamin found in our foods, and folic acid is the supplemental form of this vitamin. Now, it's interesting because I have seen people get it wrong in a lot of social media posts or in magazines. And the truth is, folate is one of the rare vitamins where its bioavailability in our body is better in supplemental form versus the natural form in food. So folic acid is more bioavailable than folate. The reason being is folate in our food is bound by glutamates, which impairs its ability to be absorbed and used in the body. Whereas folic acid in supplements does not have those glutamates. So that is why sometimes you may see dietary folate equivalent, or DFE, next to folate on the nutrition label. This term means it is estimating the amount of folate available from the food. 1 microgram of food folate is equivalent 0.5 micrograms of folic acid. So what this comes down to is supplemental folic acid has about double the bioavailability in our body versus folate coming from food sources. Now, the greatest food sources of folate include green leafy vegetables. Half a cup of boiled spinach, for example, gives 33% of our daily requirement. 1 cup of romaine lettuce or spinach gives about 16% of our daily requirement. Half a cup of boiled Brussels sprouts gives 20%. Half a cup of broccoli gives 13%. Half a cup of kidney beans gives 13%. Now, nutritional yeast is a really good source, as only 1 tablespoon of nutritional yeast gives 106% of the daily requirement. Now, for folate, animal sources are very limited. The best source is 3 ounces of beef liver, which can give 54% of the daily requirement. Otherwise, things like chicken breast, ground beef, fish, and milk give only about 1 to 3% of our daily requirement for each serving. The food fortification program does not necessarily increase our folic acid intake that much, as one slice of white bread that is made with fortified flour only gives 8% of our daily requirement. A cup of a fortified breakfast cereal can provide 25%. So the fortified foods are not very likely to put us over our limit unless we're consuming a lot of these fortified carbohydrates. And with many eating fewer carbohydrates in today's age, some practitioners are calling for need to fortify other foods or to increase the number of women taking folic acid supplements in order to prevent neural tube defects in babies. So if you are in the age bracket of being able to conceive a child, you may want to look at how much folate you are taking in daily. If you are going to get all your folate from food, you can get your daily amount from just 1 tablespoon of nutritional yeast. Or you can combine, for example, half a cup of boiled spinach, 1 cup of romaine lettuce, 1 cup of Brussels sprouts, and 2 slices of bread with fortified flour. That would get you to your daily requirement. So if you are not taking a vitamin supplement, you have to ask yourself, are you eating enough green vegetables to get your daily requirement? Conversely, if you are taking a supplement, you have to ask yourself, are you taking in too much folate? I encourage you all to take a look at your intake, because with this knowledge comes your ability to take hold of your nutrition, your choices, and therefore your health outcomes. So that is a wrap, my People Scientist Army, for episode 47. And of our vitamin series, this is episode 6. Today I talked all about folate or folic acid and how it is important for the turnover and replication of our cells and for the ability of us to repair our DNA. As a result, if we have a deficiency in folate, we may see symptoms such as low energy, pale skin, feeling short of breath, feeling irritable, gastrointestinal issues, mouth and tongue sores, and could potentially lead to a certain type of anemia, neural tube defects if we are pregnant, and some evidence suggests a folate deficiency may place us at a slight increase for the risk of some cancers due to its role in repairing our DNA and preventing DNA mutations. The best sources of folate include nutritional yeast, beef liver, and green vegetables. The requirement for adults is 400 micrograms a day, and for pregnant women is 600 micrograms a day. With the other vitamins I've covered in the past, such as vitamin C and niacin, I suggested that we may need more than the requirement to reduce our risk of chronic disease. However, for this vitamin, I do not think this is necessary, as the tolerable upper intake level is set quite closely to the recommended amount. So if you try to get somewhere between 400 to 1,000 milligrams a day, I think that is the best recommendation. If you have any follow-up questions, please feel free to message me on any of my social media platforms. And make sure to follow me on Instagram, Facebook, Twitter, LinkedIn, or TikTok so you can see the papers I cite throughout the episode and to get extra tidbits of information on the week's topic. So I hope you all have a super healthy week, and I will meet you back here the same time and the same place next week on the People Scientist Podcast. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.